thanks again for the opportunity to come back and speak to everyone at WoodSolutions. Great to be back. Great to talk about a topic we've done a lot of work on here at Melbourne Uni in collaboration with Forest and Wood Products Australia over the past few years, and hopefully help you out a bit today in understanding what the requirements are, what the new requirements detail, and how we can go about achieving them for our homes throughout Australia. Great. So today I'll do a bit of an introduction about the context, what's driving this change in Australia, what are some of the targets, before diving into the latest NCC and what is NatHERS, for those of you that are maybe not as familiar. And then we'll dive into the study itself. So the study assessed a range of homes in a range of locations to try and understand what combination of building elements, materials, and arrangement can give us better performing 7-star homes, and we'll summarize those results for you. Thermal bridging has also been investigated. We looked at both steel and timber framed homes and the impact that has on the R value of a wall, but also the overall thermal performance of a home built with each material. And finally, we'll wrap it up by giving you 7 recommendations to meet 7 stars. So thank you, Alistair, kindly for the introduction. I don't actually think I have to say anything because Alistair's covered it off really nicely. So thank you for that. So let's dive in. What's driving change in Australia and the Australian housing market? So these have been updated relatively recently with the latest federal government and the targets. So we have currently a 43% reduction in emission levels between 2005 for 2030. So 2030, as we know, is not very far away now. So there's some pretty significant changes that will need to come into play to meet that target. And even more so by 2050, where we've committed to net zero. Where do buildings fit in this climate change scene? Well, they're pretty significant, with about a quarter of Australia's greenhouse gas emissions coming from buildings. That's not just resi buildings, it's also commercial buildings, but nonetheless, a significant chunk of the emissions. 42% of our residential energy use, so in our homes, is from heating and cooling our homes. So that's again, a really large proportion of that energy is just to keep warm or cool in summer. So new policies are put in place around reducing these emissions, improving energy productivity, reducing household bills as well, as we're all acutely aware of the rises in energy costs, and also helping to transition to more renewable energy and zero emission vehicles in the future. So the NCC's played a role in many of those goals and policies. So housing in Australia, so many of us are probably working in a particular state and are quite aware of what's happening in that state or that city. But around Australia, we have got quite a few differences. The national average for a NatHERS star rating, we'll talk about that soon as well, what it represents if you're not fully across it, is 6.2 for houses and 6.4 for apartments. The current minimum is 6, that will be increased to 7, which we'll also talk about very soon. Most houses have got a metal roof, brick veneer walls, concrete floor, pretty familiar stuff. We're getting larger houses being built each year as people want bigger homes. The ACT is really leading the way with energy efficiency, and they're just on almost 7 stars already, with 41% of their new homes being built are 7 stars currently, which is quite impressive. And we're getting around 200,000 homes, new homes built in the past year in Australia. So we pulled out a little bit more data with respect to various states. So looking at Australia-wide versus just in Victoria, both homes and apartments. Houses in Victoria not doing so great compared to, say, ACT with a 6.2 average star rating. If we look at apartments, they're doing quite a bit better for a range of reasons, but principally it is generally easier to achieve a higher rating with the apartments, given the fact that we haven't got losses from the roof and the floor between those levels, except for, of course, the very bottom and very top apartment. So easy to achieve a bit higher ratings there. You can see the average star ratings quite high. This one is an important slide to also highlight growth. So there's a range of thoughts around this in that, do we let industry drive itself and the consumer demand for energy efficiency, is that sufficient? Or do we need regulatory policy to step in and mandate higher star ratings? So on the right here, it's a bit of a messy figure, but maybe just look at the grey line here. It's showing the average star rating of homes in Victoria between 2016 and 2022. It looks like it's trending up if you look here from the left to the right. But if we look at the scale here, we've gone from a bit over 6 stars to a little bit over 6.2 stars in over 5 years. So the market is not moving itself. There's no drivers internally. Consumers aren't all demanding higher efficiency homes without some regulatory change. And you can see this mimicked on the left. The vast majority of homes built in Victoria, a 6-star is basically the bottom line here. And we haven't seen significant change in that over the last 5 years, a few percent more 7-star homes. So, of course, that's where the latest 2022 NCC comes in with really some massive changes in the energy efficiency front. So some of the biggest changes we've seen in over a decade in this particular code for detached or residential housing. So what are the changes? There's a range of them. I'm going to be focusing today's talk on the new minimum of 7 stars under the NatHERS scheme, but there is a range of other ones that I'll loosely allude to so that you're at least aware of them. They've introduced a whole of home annual energy use requirement, which I'll talk briefly about. They've updated the deemed to satisfy elemental provisions. So that's, how much insulation you need to put in a wall of a certain type or the ceiling, for example. And that's quite comprehensive now, much more detailed than it was in previous revisions. They've also allowed for electric vehicle charging and condensation management sections being enhanced quite significantly as well. I won't talk about that today. So you've heard about star ratings a little bit. What is it? What does it mean? Probably the majority of you here today know all about it, but for those that don't, it's a nationwide scheme that gives a star score between 1 and 10 for a home. It's compulsory for new homes to have this unless they go down a deemed to satisfy approach, but the vast majority of new homes are doing this NatHERS energy assessment approach. It only includes heating and cooling energy for that home to keep it at comfortable temperatures. It's not including currently energy from plug loads or lighting as it currently stands. It also currently does not include thermal bridging from, say, steel or timber. 10 stars is a really high-performing home, equivalent to a passive house standard. 6 stars is the current minimum. 7 stars, which the latest NCC has come out with, is due to be the minimum by October next year. So the second update from the NCC that I alluded to was the whole of home approach. The really important thing to be aware of here is this is discrete or separate from the NatHERS star rating. So it's an additional score that homes will need. It's a score out of 100, the minimum 60, and it allows for heating and cooling appliances, hot water, lighting, and if you've got a pool and spa, pumps associated with that, as well as any on-site renewables. So if you've got solar PV panels on the roof, they will offset. So the intention is of this to reduce the energy use from those major appliances in the home and improve efficiency beyond just the thermal envelope that NatHERS traditionally covered. So if you have a home that has more demand in some of these respects, then it would need a larger solar PV array to offset that. So who's adopted the changes? Well, not everyone. Tasmania has stated that they will consider, which is a pretty loose term, the 7-star provisions in 2025. So they've really pushed it back quite considerably. Their justification for that is that Tasmania is almost all renewable energy on their electricity grid with so much hydropower. So they're not, they don't need to consider energy efficiency as stringently as other states. And the Northern Territory has not adopted it, and they've made no indication of exactly when or if they will. and they're still allowing some 5-star homes to be built. So the Northern Territory is definitely one that hasn't really taken on board a lot of these considerations. If you look at the volume of housing in the Northern Territory, though, it is almost trivial compared to those states along the east. So nonetheless, interesting to know not everyone's adopted. The vast majority, the other states have adopted, in effect, the new standards with some minor changes, which aren't worth talking about today, but they're the main things to be aware of. Okay, so just from the NCC's perspective, what are these savings going to actually deliver? Is it, what's the advantage of going from 6 to 7 star? Well, we did this study across some major cities in Australia to see what the benefit might be to go from 6 to 7 stars. So Melbourne I'll focus on, but you can see the table for the other states, other cities there. To go for just heating and cooling costs for a typical Melbourne home might be $700 a year. And if we upgrade that home to 7-star, that energy demand decreases and our costs decrease by around $200 a year. That's great, but that can be further improved by the whole of home approach. So the whole of home approach is about the efficiency of the appliances used to deliver that heating and cooling. So we've assumed here that we would increase those efficiencies to around a 3-star heating and cooling mark, and that reduces our bill by a further $100. So the approach of the NCC by taking both a 6 to 7-star NatHERS improvement, as well as the whole of home, will deliver reduced costs for consumers by improving the efficiency of their appliances as well. That obviously varies depending on where we're located, with the biggest benefits being in those cities that have the largest energy use, particularly in the cooler climates there like Melbourne and Hobart. So hopefully that sets the scene, gives you a bit of a taste for what's happening, what's coming and why. Now I'd like to talk about the study we actually did. So this was sponsored by Forest and Wood Products Australia to basically look into what would we need to do to build 7-star homes. This was done back in 2021. We've done some updates since then to allow for the latest NCC changes, but broadly we were on track with what we predicted them to be. So as part of the study, we wanted to assess building fabric, so walls, floors, glazing, insulation, all the main ones across Australia. So you can see the red dots there of the locations that we assessed. We assessed a few different homes. We assessed a HIA standard home alongside a 2-story volume builder home, and we looked at different strategies to meet 7 stars. We then did a separate investigation into thermal bridging and looked at both steel and timber framed wall systems, which we'll talk about right at the end of today's presentation. So here's our HIA standard home. We'll focus on this one today, although I'll allude to results from the other volume builder home as well. But just in the interest of keeping the amount of information reasonable, we'll talk about this principally. So our standard home, pretty basic layout, 3-bedroom, formal lounge, family dining, kitchen area. We had a base case, and from that base case, we varied different parameters to see how much better we could get the home to improve. We started off with a 6-star home, bare minimum compliance, and started adjusting different fabric options. This home had, our standard cheapo aluminium framed windows. This one had a subfloor with R2 insulation and standard R4 ceiling insulation. So let's see how different variations affected this home. We started by looking at walls. So brick veneer being our base case. We then went on a range of variations. There's no need to necessarily dive right deep into this list, but probably covered about 95% of wall types we would see here in Melbourne and around Australia, with a particular focus on our lightweight, so James Hardie or fibre cement sheet, as our common alternate to brick veneer as well. And what did we find? Well, this slide, probably shouldn't start on this slide. It's a little bit disappointing. We found that actually the wall type did very little to impact our star rating on our HIA standard home. So I'll show a lot of these graphs. And as such, I think it's probably wise to explain what they mean on this one. It looks a little bit overwhelming, but they're not too bad. This orange line at the top here, is showing heating energy requirements. So high is worse and low is better. This grey line here shows cooling energy requirements for each system. Obviously, high is worse, low is better. The final thing that these graphs show is the change in star rating. So if we're getting an increase, that's obviously a good thing, and a decrease is a bad thing. So over our base case, remembering, was our 6 stars. So ones that are 0.1 above 6 stars, that's achieved a 6.1 rating. So these are acronyms that maybe don't make heaps of sense. I'll just pull out the ones that are of interest each time we look at one of these figures so that you get a feel for what changed our results. First up, our lightweight direct fix, so our fibre cement cladding, decreased our performance by 0.1 of a star. Very little change. Wall systems that improved our performance were cross-laminated timber and reverse brick veneer. So some pretty uncommon wall build-ups, but ones that have quite a lot of thermal mass in them, actually gave us some benefits, but still very minor benefits for our homes there. So with that in mind, we thought, well, let's move on to our next building element, because clearly changing wall types in isolation is not a great strategy for getting better performance. So we honed in next on glazing. We assessed a range of frame types from aluminium to PVC to timber, as well as glazing units, from double glazed clear to double glazed argon filled, low E, and combinations therein. What did we find? We found, as I'm sure the vast majority of you would expect, much better performance from our double glazed units, especially our higher performing double glazed units. So again, our baseline single glaze, low E, pretty common windows, achieved our 6 star. And if we look over to the right-hand side here, we've got our high performing double glazed, low E. This was timber framed, but they could just as easily be UPVC framed. Timber and UPVC perform on par in terms of thermal bridging, so similar in terms of thermal performance. But if we applied this glazing unit, you can see we're getting a full star, or a bit more than a star of benefit. So to change our HIA home to a 7-star home, in theory, all we need to do is just replace the windows with a higher performance unit and change nothing else about our home, or we've achieved 7 stars. Now, many of you will be thinking, oh, that's easy to say. It's actually quite costly, especially timber-framed windows. And yes, we most certainly agree with you. So we'll provide some mix and match solutions as we go through here. But it's good to note that just the glazing on its own is sufficient, in this case, in Melbourne, to achieve our 7-star. Our double glazing clear didn't actually provide anywhere near the benefit as we start to go to these high performing units. However, it's well worth noting that this is a combination of both the frames and the glazing units. So this is an aluminium frame that's not thermally broken, and that in turn means it's not performing as well either. So we'll look at that closer as we go through. Next up, we looked at a range of other building elements or materials and how they affect our star rating. So what did we find? We might go from our best performing on the right-hand side here down. So what was the biggest single upgrade we could do to our Melbourne home, aside from these glazing units, was changing it to a waffle pod. Now, the waffle pod being polystyrene voids in a concrete on a concrete slab gives a few benefits to our homes in Melbourne. Note, this is only for Melbourne. It insulates the floor a bit better, but it still gives thermal mass. In the software, that's how it's modeling it. So we're getting some benefits there of around 0.6 of a star. Other benefits that we saw was edge insulation around our concrete slab, if we just had a concrete slab on ground. If we changed our subfloor to a slab on ground, we had marginal difference, so 0.2 of a star. If we increased our subfloor insulation to R3, we also had a little bit better performance. And the same goes for increasing our ceiling insulation a little bit. So as you can see, in isolation, most of these changes definitely don't get to 7-star on their own. So they're adding a little bit at a time. One of the obvious questions is, can we just sum these together? Can we add a slab on the ground plus our ceiling insulation plus our edge insulation and do these changes in star ratings simply add up? The answer is not quite. So as we get higher in our star rating, we get diminishing benefits. So it's not exactly as simple as just summing them up, but it's not far off. We might, if we add all three of these, for example, not get 0.6, but 0.5 of a star benefit. And we'll talk about how we combine these shortly. Things that made negligible change in our rating was the color of our roof, although dark color actually made our home perform less favorably, and a reflective roof space also did not assist this home. So with that knowledge on board, we mixed and matched and found some combinations to achieve 7-star. And what did we find? Well, we found pretty much all our solutions needed upgrading of the glazing units, with the exception of this option here, whereby we just changed our frame of our windows to either UPVC or timber, and we could actually keep single glazed home and meet 7-star. However, we had to upgrade a few other elements in our home. We had to upgrade the wall insulation to R2.7, and we had to have a waffle pod slab. Still not, drastic changes to get to 7-star in this particular item. All other items had some form of upgrade to our windows, typically better wall insulation, and a range of different subfloor insulation. So if we had our subfloor in Melbourne, we did need to bump its insulation value up above 2.5 to achieve 7-star, whereas the waffle pod in Melbourne definitely achieved 7-star more easily with less significant changes to other building elements. We could also get a 7-star home with just a concrete slab on the ground, but we needed some pretty serious ceiling insulation and wall insulation as well. So I guess the common theme here is a combined approach typically delivered our 7 stars, unless we just went really high performance glazing units. So what happens when we try and push our envelope a little bit further and get higher star ratings? Well, we could get up above 8 stars for Melbourne, but we needed really an all-in approach. So let's start changing a range of our elements and making them really high performance. So we looked at high performance glazing combined with our wall types that performed very well, such as our reverse brick veneer or our CLT. Again, these wall units are performing really well because we also had the added advantage of thermal mass on the inside of our insulation for both the reverse brick veneer and our CLT. But we also combined that with edge insulation, R6 ceiling insulation, and we could get over 8 stars, but obviously at a cost. This is not coming cheap, and they're very bespoke wall build-ups. We could get near 8 stars with a standard brick veneer home, with a variety of other measures, but we really needed that R6 ceiling insulation. For none of these options could we get near 8 stars without R6 ceiling insulation. Probably most of the viewers today are not so worried about 8 stars as 7 stars, but it's interesting to know that we can push that boundary further as required. So with that knowledge on board, we thought, well, let's expand this study out and look around Australia. So we redesigned our HIA home and we made it high performance. We made it essentially a 7-star home and then moved it around Australia and changed a range of variables to see, well, how did this home perform in different climate zones? And what could we take away in terms of the design and still achieve at least 7 stars? So our new designed home, again, was still brick veneer. We assessed a concrete slab on ground, we assessed a waffle pod, and we assessed a range of the major cities that we discussed earlier. We're going to start with cool to mild temperate zones. So Hobart, pretty tricky climate, quite cool, a lot of heating requirements. Our base case home, our redesigned home got 7.3 stars, fantastic. And we varied a range of parameters here to see what changed. Now, remembering our base case home had a waffle pod floor this time, our newly designed home. And what did we find in Hobart? Really interestingly, we found a subfloor actually was really helpful. Well, really helpful, was beneficial, I should say, with a 0.1 star improvement over the waffle pod. And this improved further as we got more insulation on the subfloor, but showing the decoupling of the ground in Hobart, in these really cooler climates, was of benefit. We found if we downgraded our windows much, we definitely did not achieve 7-star. If we went to a concrete slab on ground instead of a waffle pod, we only just achieved 7-star. So this is minus 0.3 from 7.3. And if we mixed and matched our glazing in our day use spaces only, not putting them in our bedrooms, we could still achieve 7-star and save a lot of cost for our homes. And I'll talk about that a bit more later. It's an important point. Melbourne had similar trends, although now our subfloor actually decreased our performance of our home by 0.4 stars instead of increasing it a little bit. Our base case home achieved 7.5 stars, and we can see pretty similar trends to what we witnessed earlier for Hobart. Again, with our lightweight cladding compared to our brick veneer, hurting our star rating or decreasing it by 0.1 stars as well. So no problem achieving our 7-star rating in Melbourne with our newly designed home, but it definitely made sense to have either a well-insulated subfloor or a concrete slab on the ground with a waffle pod. We could still achieve our 7-star again with just having high performance glaze in our day use spaces. So a summary of those findings, I've talked about already to a large extent. We did find that the frames of the windows were really important. So either having thermally broken aluminium frames, PVC frames, or timber frames was really important to not allow that thermal bridging around the windows. And we typically got around a 0.5 star boost just from upgrading to double glazing. And as soon as we had included thermally broken frames, or as I said, timber or UPVC frames, we got up to 1.6 stars additional from that high performance glazing. So really big boosts, especially in Hobart, from that high performance units. This is an important point though, and one that's not mimicked around Australia, but definitely for the cooler climates, was our double glazing in our bedrooms didn't really help that much. We only were achieving another 0.2 stars for double glazing all the bedroom spaces. Not only is that because they're not conditioned for the same times, they're not conditioned to the same stringency or the same temperatures as our day living spaces in our kitchens. So what bottom line is, this was not as important in our bedrooms to have such high performance glazing. So good cost saving measure for builders, maybe not double glazing in the bedrooms for cities like Melbourne. It's not giving necessarily as much benefit as the main living areas. Okay, so moving a little bit warmer, our warm temperate climate zones now. We're looking at Perth. What did we find? Well, we found our HIA home did really well. We were at 8.2 stars now. So what does this show us? It shows us that it's easier to achieve this star rating as we have less extreme climate, so a more mild climate. We found the subfloor really hurt the Perth home without that ground interaction. So definitely the concrete slab on the ground or the waffle pod was preferable there. But we could still achieve everything over this line here is a 7-star home. So the only homes that didn't achieve 7-star were the subfloor, our completely single glazed home, were the only two that didn't achieve our 7-star. Our double glazing in just a day spaces could still achieve a 7-star home in Perth. Sydney was a similar story with, again, a really high 8.4 stars from our redesigned HIA home. And in fact, all our parametric analysis for Sydney still achieved 7 stars, even downgrading all our glazing to single glazed low E units. We still were getting over a 7-star home. So what the bottom line here is it's relatively easy to build a 7-star home in Sydney compared to, say, Melbourne or Hobart, with much less energy requirements for both heating and cooling. You can still see from this orange line being above the grey line, we've still got more heating than cooling in Sydney, but nonetheless, this home performed really well. So the summary is pretty similar to what we've discussed already. And we're getting about 1 additional star from our higher performance glazing compared to our single glazing in these warmer climate zones. So let's move further north. We'll move up into Brisbane and see what happens now with our warm, humid summers. Again, really good star rating. So less challenges compared to Melbourne. However, our glazing is starting to have a bigger impact again. So in Sydney, it wasn't as significant, but now we're up in Brisbane, massive impact. So we can see our single clear glazing actually dropped us almost 2 stars. So we're at 6.4 star. All of a sudden, this parametric assessment, this home doesn't get 7 stars anymore. It's 6.4 stars. So the double glazing in Brisbane was important. And more important in the bedroom spaces than in Melbourne. Our subfloor was also not a good solution for Brisbane, decoupling the floor from the ground, especially when our vast majority of our conditioning requirements were cooling. We really benefited from having that slab on the ground. So not great solutions for Brisbane. We found a 70 mil wall frame was actually just fine to achieve still over 8 stars in Brisbane. So having, thick, heavily insulated walls is just not really that essential in Brisbane to still achieve a high-performing home. So based on those study results, we discussed this with a range of other industry partners and got some feedback on what else would be of interest to assess. And one of the things that came up was eaves. As we see in a number of the more modern homes, in fact, almost that one in the grayed out picture behind us, but eaves are not necessarily always being built on new homes. So how much difference do eaves have on our performance? So again, we took our standard home base case and we just took the eaves out and see how it would impact things. In Melbourne, we had surprisingly no change in our star rating. For Sydney, we found it actually was giving us quite a big benefit. So if we removed our eaves from our home in Sydney, we lost 0.3 stars. The same happened for our Brisbane subfloor, and it was even more pronounced for our Brisbane with our concrete slab on the ground, because now that concrete slab's absorbing a lot more of that solar heat gain with its thermal mass and really making the house hard to cool off overnight. So takeaway message, the eaves are of greater importance where we have more cooling requirements, which is, I guess, no surprise. So this particular slide, I know I will get some questions on how did you get these costs? And these costs are, well, now outdated, so they probably do need to be updated. And I apologize, I didn't quite get time to do that. But cost for glazing, as many of you in the building industry know, it's gone up significantly. So this was using pre-COVID sort of costing data here. But what we did here was we said, well, we need to meet 7 stars, but what about mixing and matching where we double glaze? The living spaces, the bedroom spaces, both spaces, where's our sweet spot in terms of cost and still getting that 7-star rating? So the blue lines are our star rating. So obviously we're looking sort of to the right of here. We're looking to minimize cost. Well, any of these ones with day are just doing the day use in living spaces. Only upgrading those glazing units and leaving single glazed in the bedrooms. What we can see is reduced costs, relatively speaking, compared to doing all our windows, which obviously makes sense, but still reasonably good performance for Melbourne. So as we've discussed before, definitely a good sweet spot of upgrading not every single unit to double glazing, but the ones that are of most importance. For Brisbane, we didn't see as pronounced a shift in the star rating. And what we found was actually it's becoming more important to double glaze those bedroom spaces. And I guess that's because we need to condition or keep our rooms cool enough to sleep in Brisbane, especially in those hot, humid nights in summer. So Brisbane becoming more important to insulate all the windows, with some of the cost optimal solutions being around this mark here. So one of the final takeaways from this, and probably I'd say if you take away one thing from this presentation, this might be it. But the impact of wall and window performance in the overall system value. So system R value, I should say. Two lines here. The blue lines for a single glazed wall window unit with 20% window to wall ratio. The orange line is the same, but now with double glaze. And what we're showing here is if we increase our wall insulation, what happens to our overall insulated value of our system? For our single glazed unit, even if we go from an R value of 1.4 all the way up to say 4, which is insane, but a huge value of insulation, we only get a tiny benefit in the overall R value of the wall. That's because all our heat loss is going out our single glazed window. So the takeaway message is there's no point in upgrading wall systems without upgrading the window systems. We see conversely for our double glazed unit, if we go from a lower R value on our wall to a higher R value, we're now all of a sudden getting a big boost in our performance because our glazing isn't just losing all that additional insulated value. So moving on to thermal bridging, I don't have a lot to say on thermal bridging, just a high-level summary. We looked at a range of different methods for assessing thermal bridging, and we did that for both steel and timber. We're going to focus on this method here, which is the standard method in Australia. And what we found was for a timber frame, we definitely saw a decrease in our performance and a more pronounced one for our steel frame, regardless of whether it was lightweight, direct fix or brick veneer. Both negatively impacted the performance, the R value of our system. The steel more than the timber. There's two ways to combat that, one with thermal breaks and one with more insulation. We found a thermal break to make the steel and timber perform comparably similar. We would need, and again, we did two standards here, so let's just look at the blue line here. We need a thermal break of 0.32 R, so that's a continuous or a sheet of insulation between the steel elements and the wall of at least 0.32 to make sure that our timber and our steel framed homes performed on par or the same. If we try to achieve the same, so the same performance between steel and timber framed home with just adding more insulation, we actually had to add 3.4 R value of insulation between the studs to get the same performance. So again, clearly an inadequate way to address thermal bridging, but just to make it abundantly clear, we can't address thermal bridging, which is more insulation between the studs. We need a thermal break. So how much difference does it actually make? Well, CSIRO's done a bit of a study for the whole of house. So for a timber framed home, thermal bridging reduces our star rating between 0.2 and 0.4 stars. So a reasonable amount. And metal framed homes are dropping between 0.7 and 1.2 stars. So pretty much just a full star rating reduction from thermal bridging. Now, the software currently does not include thermal bridging as it currently is. That's not included in the assessment. However, the latest NCCs sort of included it. Now, you can read this 10 times and you'll still probably be a little bit confused. I certainly was. So I'll paraphrase, I think, as to how I interpret this latest change. Steel framed homes are now, the thermal bridging in those homes is taken into account only to the extent that it's equivalent to timber framed homes. So they're making a level playing field for steel and timber framing, which is a good thing. We want to be closer to the truth on the accuracy of thermal modeling, but it's still not fully included. So these homes we're modeling in this software are still not perfect, I guess. So the final summary, I think I've covered off on this to a large extent. There's probably only one point that wasn't made abundantly clear, and that was we also found that narrower lot homes with less access to solar or less solar access definitely had bigger challenges in meeting those 7 stars. So I haven't looked at that in great detail today, but definitely, more difficult lots present unique challenges, and we have to, look at many more of those building material elements to achieve a better star rating. Well, I always get questions about, does the software do this? Does it do that? What are the limitations? Well, thermal bridging is still not really taken into account. The software also assumes air tightness is the same, or air changes per hour are the same, no matter how you build the house, which is obviously not fully representative. It doesn't really adjust for occupant behavior from, say, people working from home versus going into the office. It just makes blanket assumptions that people are, getting out of the house and going into the office. It also doesn't include earth, slab, groundwater interactions, and that can be quite significant in regions with higher groundwater tables. So be aware that, the high groundwater table, concrete slab on ground, it's probably a bit of an issue for heat loss. And finally, there are some variations between assessors and software. We know there shouldn't be, but from what we've seen, two people can do the same home assessment with two different bits of software, some slightly different assumptions, and get slightly different star ratings. So be aware that's the case. It's not 1-star rating is what everyone will get for the same home. So I'd like to finish up with 7 take-home recommendations. You've probably already got these in your head from if you've been listening. But number 1, get the assessor involved early in the design process. They will identify things for design that will help your home right from the onset, whether it be glazing, locations, shading, solar access, etc. So critical, get them before the home's finished, because it's harder to make changes to the design later in the process, as you're all acutely aware, I'm sure. Glazing's key. We know that. I've gone on and on about it. So definitely, especially for Melbourne, day and living spaces are the primary goal. And don't forget the frames that are glazing. They need to be either thermally broken timber or UPVC to get the maximum benefits. Design for location. So the sun can be our friend or our enemy in thermal modelling. So in Melbourne, we really want that sun in winter. So having eaves that block it in summer and allow the heat through in winter is fantastic. And the software will give you those benefits. So designing for location. You can't always do that in particular blocks and locations. It can be harder and harder. And where that's the case, you're just going to have more insulation and a high performing home in other respects. But where you can, that will give you benefits for free. Insulation. So obviously, ceiling's the most important, followed by the walls and the floor. But don't forget between conditioned and non-conditioned spaces. So insulating between the garage and the rest of the home can give you a pretty significant benefit as well. Or even between, say, bathrooms and living spaces can also give a benefit, because that bathroom's not conditioned into software. Along the same line, zoning is actually really of large value. If you can have doors or partitions between spaces, that will actually help you a lot. So one of the biggest problems we had with double-story homes was heat loss from a living space downstairs up the stairs to a large corridor or maybe another space upstairs. So having additional doors, nobody wants more doors usually in home design these days, but if we can zone, it will add additional benefit to the star rating by not conditioning as much of the home at a time. Colours are important. We've talked a little bit about this, but if you're in a warmer climate, lighter colours, darker climate, a colder climate, darker colours can be of more benefit as well. And don't forget the window frames. So the final one, fans, lighting, cross ventilation. So the software does give us benefits for cross ventilation, that is having windows or openings on either side of the home, so you can open them up and cool it off on after a hot summer's day or something. But also the ceiling penetrations can make a difference. So using sealed downlights, having ceiling fans also can give you a boost to the star rating. So there's some things that we can do that cost not really anything, but just a good design principles, and it'll give us that 0.1 or 0.2 stars and often get us over the line between, say, a 6-star and a 7-star home. So that's the presentation. Definitely welcome any questions.
Thanks for that, Phil. But no, fantastic presentation. If people do have questions, please put them in the Q&A button and the Q&A tab. No, it's really interesting the way things are going, Phil. You did mention just before about the take-up. So we've got about 12 months in most states for, before it comes in. So October next year. We've been doing a lot of work with all the different groups, HA, MBA, the glazing people, how that's all going, trying to sort of monitor how people are looking at it. Did you You might just mention when some of the software is going to be available, because that is still a bit of a problem that the proprietary software isn't out there. So a lot of the builders aren't actually able to do full assessments of their homes yet. Do you know when that's due?
Yeah, it's a great question. I don't have a specific date, and a lot of the software has been pretty open-handed about providing an exact date. The good thing is you can still use the software as it currently stands and get very good indications of how your home is going to perform. Although there's been some updates, they're not so considerable that a 7-star home in the current software is all of a sudden not a 7-star home when these latest climate files and latest star bands are updated. So you can still do those designs, Alice, there as they currently sit and have a really good indication of what is 7-star. However, the whole of home approach, so that efficiency of appliances, is still in beta version. So that side of things is still a little bit more questionable about when and what people are going to have to do to meet that whole of home requirement.
Yep, thanks. We had a few questions early on when you were showing some of the comparisons. I think during the Melbourne comparisons, Jackie asked the question when you were looking at the different wall systems and how some of those were reducing. She asked, did that include the thermal bridging effect?
Yeah, that's a great question, Jackie. And the answer is no. So we did not include the thermal bridging effect in this modelling because we really wanted it to be representative of builders or designers, what you actually have to contend with the software. So unfortunately not the reality of the thermal bridging, but what you'd actually get in the software. So we would find that the star rating of everything that's been presented here today would decrease if the thermal bridging effects were included. As we said, by 0.2, 0.3, 0.4 stars for timber, and if we substituted that timber out by more like 1 star for steel frame. So no, it wasn't included, but yeah, definitely, would be one of the things we'd love to see in the future is something like that included in the codes.
And similarly, back when you were talking about that, Peter was just asking about the orientation of the homes. He was asking what orientation was the study based on, as that'll have a substantial effect on the outcomes.
Yeah, you're spot on, Peter. And it definitely did. And for each of our models, we did, do our parametrics of spinning our home around and assessing how that impacted the star rating. And we found that we had, for our HIA standard home, about 0.3 stars of variation. So probably not quite as significant as some homes. So some homes, especially narrower lot homes, will have a bigger impact on the orientation. So we did have a bit of a look at that, and I didn't present that in detail today, but you're spot on. It does have a big impact, yes.
Yep. Harold asks how the AAC panels to external walls performed compared to the brick veneer and fibre cement.
Great question. We found it performed somewhat in the middle. So the AAC panels add a bit more insulative value than both brick veneer and fibre cement. So they've got some insulating value on their own, but they've got less thermal mass than brick veneer. And more thermal mass than fibre cement. So somewhere in the middle, it did depend on the climate. So I guess fairly comparable to brick veneer and better than fibre cement would be my short answer to that.
Mm-hmm, mm-hmm. Actually, an interesting question from David. What difference does the ceiling height make between like a 2.4 to a 2.7 metre ceiling height?
Yeah, that is a really good question, David, and one that we didn't actually include initially in the study, but once those latest deemed to satisfy provisions came out, we did reassess, and it actually hurts us quite a bit, that increase in our ceiling height from 2.4 to 2.7. So as we get higher ceiling heights, it actually gets more and more difficult to meet those, to get those higher star ratings, and that's mimicked in the deemed to satisfy provisions. So you'll see, it would have been great to have one on the slide today, but you'll see in those provisions the requirements for different wall heights. And as you get higher wall heights, the insulation requirements increase and increase. And sometimes if you've got a wall height of, say, over 3 meters, it will say there's no insulation value you can choose here to be compliant from a deemed to satisfy compliance. So higher ceiling heights make more difficult to achieve those higher star ratings.
There's an interesting question here from Dean, who's close to my heart here. He actually says, seems like the death of the subfloor. My concern would be with increasing flooding in some areas, being closer to the ground with a waffle slab is not ideal, which 100% agree with, Dean. And we've been trying to do quite a lot of work now to encourage back with building designers, to design the best sort of outcome for your site, which we all should be doing. So if you're in a flood-prone zone, really sort of, building down into the ground, into the flood's not a good solution. Building up above that is a better solution. So it is an interesting trade-off sometimes you get where you're trying to prove energy efficiency, but you might actually, if you don't think about it, you might actually be giving a more perverse outcome, which clearly, Dean, that would be the case with subfloors. And similarly, not just flood-prone areas, but sloping sites. It's not a good outcome for the client sometimes if you have to do massive excavation to get a slab down when the subfloor would be best suited. But I do know, Philip, from it might have come across a little bit with some of your comparisons that subfloors may not have been a good option, but clearly looking back to some of your initial figures, you can still get a subfloor to perform to 7-star in every climate zone if you insulate it correctly and do some of the other things. Well, what are your thoughts there? I know we've had a lot of chats about how the NatHERS software actually fairly simulates a slab on ground and its thermal linking to the ground. But I think subfloors are just the better option in different in specific.
Yeah, it's a great question, and I agree, Dean. And it's not, energy efficiency shouldn't be considered in isolation. But just on the subfloor front, we did find a subfloor as we move further north was getting worse and worse. And you're quite right. In Brisbane or in Sydney, it was hard to make a case for the subfloor unless, as Alistair said, you've got other factors, including there. However, in Hobart, it was actually a better solution than our waffle pod slab. So as we're getting climates that we need to do a lot more heating for, that subfloor was actually a real winner of a solution. So it did depend a bit, but you're right. In those warmer climates, it was a much harder sell. Yes.
The other sort of question came from Mario around eaves, which is a sort of similar thought that, where I think, as building professionals, we will have all been a bit disappointed to see eaves disappear from houses. I mean, they have a requirement there outside of just energy efficiency, like protecting your walls, protecting your windows, all those things. What are your thoughts there with the eaves results? Some of those seem a little bit interesting for the different climate zones.
Yeah, they definitely do. And it showed that the eaves were really important for those climates where you had to cool your home quite a bit. So in Brisbane, a home without eaves was really, giving you some major penalties, most certainly. And you're right, there are some other intrinsic benefits for eaves beyond just preventing solar heat gain as well. And that did, somebody else mentioned the orientation. So those eaves had bigger impacts depending on how we orientated our home too. So, the parametrics do multiply out, but you're spot on that these eaves are performing a really valuable function. However, so long as they're not too deep, especially in Melbourne, if we have some of those older Victorian style homes with a large veranda and eave, that actually really hurts our energy performance as well, because we then get no solar heat gain. So eaves aren't always, just tick box great. It's about the depth of those eaves in relation to the wall height as well. So we want solar heat in winter, but not in summer, I guess, is the key takeaway. And just on that, although it's a little bit adjacent to it, shading, external shading can also be a great way to get that benefit if eaves for some reason aren't an option. So external awnings will also give you that benefit of reduced heat gain in summer.
Blair asks an interesting question here, and he thanks you for your presentation, that most of the products you've been talking about are off-the-shelf type products. Do you see any new product designs that might really sort of assist in improving the star rating of a dwelling? I know you do a lot of work with the Building 4 CRC. Have you come across some other things we should be thinking about as building professionals?
Yeah, look, it's a great question, Blair, and I guess I'm somewhere in between. I've got the off-the-shelf on one front, and on the other front, I've got these academic or I guess cutting-edge products that haven't yet hit the building industry. So a couple things that I've seen on the academic front that are exciting that I think hopefully in the future will make an impact. Phase change materials are one of them. So materials in the walls that are changing phase right at the right temperature to give you those a better benefit than just thermal mass. You're seeing really high performing insulation materials coming out as well that are far in advance of your standard, say, glass wool. We're also seeing some more timber fiber panels coming into the market as continuous sheathing around our homes, like Passive House standard. So that additional continuous sheathing or continuous insulation mitigates all that thermal bridging. So then we're getting great outcomes from a thermal bridging perspective, and also from an air tightness perspective, which we haven't talked about a lot, but also makes a big difference to the thermal performance of homes. So there's a lot of stuff happening in that space. Yes.
We might have to wind up the questions there. We're just on midday, but thanks, Philip, for a fantastic presentation. Once again, full of great information. For people that want to access Philip's original report for FWPA, it's available from the FWPA website. So feel free to download that, go and chase that if you're after it. So thank you once again, Philip. I'll just remind everyone that the webinars are all recorded, so this will get uploaded over the next week to the WoodSolutions website. So if you want to go back and either re-listen to it or let one of your colleagues know about it, please feel free to do so. And just a reminder that our next webinar will be next year. So this is the last one for 2022. So we'll crank up again on the 7th of February. January is always a pretty quiet month. And that will be around innovative timber post and plate systems. And we've got a case study and research there from Tom Watts from XLAM and Perry Forsyth from University of Technology in Sydney. So thank you all once again. A reminder again that as of next year, we'll be going to monthly webinars, so starting from February, and we look forward to seeing you online with the same. So thanks, Philip, and thanks all everyone for joining in today.